So still on the properties of Laplace transforms, let's take a look at these particular properties also. Okay, let's take a look at the convolution property. Okay, so that's property number 8, convolution property. Okay, so the convolution property is such that if x1 of t gives a Laplace transform of x1 of s. Okay, and then here ROC is, let's say, R1. Okay, and okay, x2 of t gives a Laplace transform of x2 of what? S. Okay, and here ROC is, let's say, R2. Okay, R2. Okay, then this is what we're supposed to actually have. Okay, then x1, then x1 of t. Okay, convoluting. Okay, convoluting with x2 of t. Okay, x2 of t should have a Laplace transform, okay, of x1 of what? S. Okay, multiplying x2 of what? S. Okay, and then the ROC, okay, the ROC should be the intersection of the two. R1 intersection what? R2. Okay, so basically this is it. Okay, so let's state the general rule for convolution. Okay, we know that when you have x1 of t convoluting with what? X2 of what? T, then I'm supposed to have what? Integral minus infinity to what? Infinity. Okay, I'm supposed to have x1 of what? Tau into what? x2 of what? T minus tau. Okay, t minus what? Tau, the what? The tau. This is the general what? Formula for convolution. Okay, so from here, then let me put this one into the what? Into the Laplace formula. If I put this one into Laplace formula, then I'm going to have, let's say I want to find the Laplace of what? x1 of what? T into what? x2 of what? x2 of t. Okay, then it's going to be like this. Okay, here infinity minus what? Infinity, and this is the general convolution formula. So I'll put that one into this one. So here I'll have here infinity, here minus infinity. x1 of what? Tau into what? x2 of what? T minus what? Tau. Okay, t minus tau into what? Into the tau. Okay, into the tau. All right, so into what? Because it's Laplace transform, I'll have here what? E minus what? St d okay, E minus what? St, okay, d what? dt. All right, so basically this is what I'll have. Okay, so now if I have this first, let me deal with this particular place before. So now what I can say is that I can have integral of what? Infinity minus infinity. Okay, let's say x1 of what? Tau d what? x1 of tau d tau. Okay, x1 of tau d tau is going to okay, that one is actually coming out, and then I can have another second integral here minus what? Infinity. Okay, here I will have x2. Okay, I can have x2 of what? T minus what? Tau into what? E minus what? St. Okay, d what? D tau. Okay, sorry, I brought the tau here, so this one will be what? dt, which this dt. Okay, so I can rearrange my equation in this particular manner. Okay, in this particular manner. So now if I do that, then basically this one becomes the what? The Fourier what? Transform. This becomes the Fourier transform. Okay, for x2 of what? S. For x2 of x. x2 of s. Okay, so now here I can say that if x2 okay, if x2 of t has a Fourier what? Has a Laplace transform. Sorry, I've been saying Fourier. Laplace has a Laplace transform of what? X2 of what? S. Okay, then I can say that this place I'm actually supposed to have then x2 of what? T minus what? Tau. Okay, we'll have a Laplace transform. A Laplace transform, okay, which is going to be E minus S, okay, E minus S of tau into what? X2 of what? X2 of S. Okay, so basically that is what actually I'll have here. Okay, so now here what I can also say is that then this integral that I have here, okay, x1 of what? Tau is going to actually multiply this one, so minus s of what? Tau, okay, into what? X2 of what? S, okay, into x2 of what? S, okay, the what? The tau. So now here, this one also give me x1 of what? S. So now I'm going to have this one also giving me x1 of what? S, and then this x2 of what? X2 of what? S. Okay, so that means that I've actually been able to what? Achieve all of them. Okay, I've actually been able to achieve all of them. Okay, so now because here I could have also written it in this particular manner. I could have said that x2 of what? S, okay, here like this. Okay, so x1 of what? Tau into E exponent minus S of what? Tau d what? D tau. Okay, so this one will give me this. So now what I can say is that the Laplace transform, okay, Laplace transform here, x1 of what? T into convolution, okay, x2 of what? T, Laplace what? Transform is what? x1 of what? S into x2 of what? S, okay. So basically, this is how you can do this one. And then your ROC, and then your ROC, okay, is what? R1 intersection what? R2, okay. Basically, that's how you can do this one. All right, okay. So we can go to the another property, okay. Okay, so our next property shall be property number 9. Okay, this is called time scaling property. Time scaling property. Okay, and here if x of what? T has a Fourier, a Laplace transform of what? X of what? S. Okay, and then it has an ROC of, let's say, R. Okay, then what I'm going to have is that x of what? 80. Okay, we'll also have a Laplace or transform of 1 over what? Mod A. 1 over mod A into what? X of S. Okay, of S over what? A. Okay, and here I will have an ROC of what? R over what? A. Okay, R over A. So let's see how we can actually prove this one. Okay, let's see how we can actually prove this one. Okay. So now to prove this one is what? Mod A. Mod A means that we have to take both the negative aspect and then the positive aspect of the mod. Okay, of the mod A. So the case 1, we will take the positive aspect. Okay, so case 1. Okay, A is greater than what? 0. We take the positive aspect. Okay, so now here, Laplace transform of x of what? 80. Okay, 80 here, which is this 80. Okay, is going to be equals to here, Laplace is what? Infinity minus what? Infinity. X of what? 80. Okay, into E minus what? ST d what? dt. Okay, so we can say that 80, okay, we can see that let AT equals what? Tau. Okay, so that you can have the T is equals to what? The tau over what? Over A. Okay, the T is equals to the tau over A. Okay, so now here what we can say is that the Laplace transform will now become what? Infinity minus what? Infinity, okay? X of what? Tau. Okay, here becomes what? Tau, because of here. Okay, x of what? Tau into what? E minus what? S. Okay, I have t here. What does this t become? Okay, now this t becomes what? It becomes tau over a. Okay, so now I can say that s over what? A. Okay, into what? Tau. Okay, into tau. And then here, this dt becomes what? The tau, because of here. The tau. But it becomes the tau over a. So I can send that a here. Alright, I can send that a here. So now what I'm going to have is that I'm going to have 1 over what? A into what? Infinity minus what? Infinity. Okay, x of what? Tau into e exponent minus s over what? A into tau the what? The tau. Okay, so this is what I'm going to have. So now if you check into this one, okay, what you can see is that basically this one, if I take away this 1 over a, you take away this a, then is a what? Laplace transform. That gives us what? X of s. Okay, so is a Laplace transform that gives us x of s. Okay, so now what I can say is that this one is actually equals what? 1 over a, and here if I take away this one, then is the Laplace transform that gives me what? X of what? S. So now let me bring this a what? Here. Okay, so this is what I have. Okay, so now what I can say is that, okay, then basically my what? X of what? 80, okay, is giving me a Laplace transform. Okay, it's giving me a Laplace transform, okay, of this, which is actually what I set out to what? To prove, which is this one. So now I can say that it is what? Proving. And what is my ROC? My ROC is such that R over what? A. Okay, so now let's go to the case 2. So in the case 2, A is less than 0. Okay, in the case 2, A is less than 0. A is negative. So if A is negative, then Laplace transform of x of what? 80. Okay, here is minus what? 80. Is going to be equals to here. Okay, x of what? X of minus what? 80 into e minus what? St the what? The t. Okay, so here what I can say is that let minus 80 equals to what? Tau. Okay, so that the t is equals to minus the tau over what? A. Okay, the t is equals to minus the tau over a. So now here what I can say is that if I put that one here, then I'm actually going to have integral of what? Infinity minus infinity. Okay, x of what? X of tau. Okay, x of tau into what? Into e minus what? S. Okay, minus s over what? Over a. Minus s over a. Okay, minus s over a into what? Into tau. Okay, into tau. Into tau like this. Okay, but here what you have to know is that this is going to be what? Minus what? T is equals to what? T is actually equals to what? Minus tau over what? A. So here I'm supposed to have minus over here. Okay, so the what? The tau. But it's what? The tau over A. But the t is equals to what? Minus the tau over A. So I'll bring here minus what? A. So basically this equation now becomes what? Minus 1 over A. Integral of what? Infinity. Integral of infinity minus infinity. Okay, x of what? Tau into what? E. Okay, minus what? Minus s over A into what? Tau. Okay, the what? The tau. Okay, so this is how this equation actually now what? Becomes. Okay, so now if it becomes this way, then my proving is almost what finished, because I know that everything here, if I take away this a and I take away this what minus, then everything, I take away this a, I take away this minus, then everything here is a Fourier what transform that gives me x of what s. Okay, so that means that everything here is a Fourier transform that gives me what x of what s. Okay, so now what I can have here is that I'm going to have here to be equals to minus 1 over what a into what into x of what s, okay, over what a. Okay, but here there is a minus here. Okay, so this what minus. Okay, all right, so basically that is what I'm going to actually have. Yeah, so this is going to be how we can actually get this one. But there's another thing that we can also do. Okay, if we want this negative to disappear, to disappear, then we can also say that the limits should change so that here becomes negative infinity, here will become 1 over a, and then here becomes what positive infinity, and I'll have x of what x of tau into what e exponent minus what minus s over what a into what d tau into d tau. Okay, so if I have it this way, then in that case I'm going to have my answer to what 1 over what a, 1 over a. So here you see that if I take away this a, if I take away this a and I take away this minus, I take away this a, I take away this minus, the rest of the thing here represents what the Fourier, the Laplace transform, which gives me what x of s. So here becomes what x of what s. Okay, so I took away the minus, so if I bring it, I'll have what minus s over what a. Okay, so this becomes my answer. Thank you so much, and see you in the next lecture.